topic, the dot product. Definition: the dot product of two vectors, v equals ab and u equals cd, can be calculated by v dot u equals ac plus bd. So this dot is us defining a new operation called the dot product, and we can apply it to vectors. And so notice what happens. On the left side, right, the input is two vectors. So I say, hey, give me two vectors. And then the output is going to be a times c, so the horizontal components, plus b times d, which is the vertical components. And a times c plus b times d is actually just a scalar, right? It's just a regular real number. So what the dot product, what we can think of, is I start with two vectors and end up with just a number or a scalar. Why do we care about the dot product? Well, there's a few different reasons, but let's look at the first one. To find the angle between these two vectors, v and u, I can use this formula. The cosine of theta is equal to the dot product of these two vectors divided by their magnitudes. So I have cosine of theta equals v dot u all over the magnitude of v times the magnitude of u. So let's look at an exercise. Find the dot product of v1 equals 5i plus 2j and v2 equals 3i plus 7j. Then find the angle between them. It can help to write this. And notice that these aren't written as v and u. They're written as v1 and v2, but that doesn't matter. We don't need an exact sketch here, but it's kind of nice to just see what's going on. So let's see, v1 is over 5 up 2. So 1, 2, 3, 4, 5 up 2. So about right here. And this we'll call v1. And then v2 is, 3i, 7j. So over 3 up 7. 1, 2. Okay, about here. And again, this is just, I don't know why I'm being so exact here. Here's v2. So it just kind of gives us an idea of what's going on. We're going to find the dot product, but it wants us to find the angle between them. So now I can kind of picture this angle a little bit better, knowing that these two vectors are both in the first quadrant. Okay, so find the dot product. So the dot product, you want to start with just writing what that would look like. So it's just v1 dot v2. Okay, and what is that going to be? Well, it's 5 times 3 plus 2 times 7, which is 15 plus 14, which is 29. So there's my dot product. And then it says, okay, well, now find the angle between them. So what's the angle between them? Well, cosine of theta, right? At first I need to start with cosine of theta before I isolate theta. So is the dot product 29 over their magnitudes? Well, I haven't found their magnitudes yet, so I'm going to go over here and do that. The magnitude of v1 is the square root of horizontal component squared plus vertical component squared, which is the square root of 29. So square root of 29 goes down here. v2 is the square root, magnitude of v2 is the square root of 3 squared plus 7 squared, which is 9, and 49 is the square root of 58. So this is the square root of 58. Normally I could use my cosine inverse here right away if the right side wasn't nice, but I noticed that there's something kind of nice going on here. So we'll do a little bit of solving by hand just because we can. So all I've done is rewrote 29 over root 29. Root 58 is the same as root 29 times root 2. Now, why do I care about that? Well, because 29 is the same as root 29 times root 29. So what this simplifies to be is 1 over root 2. If I rationalize the denominator, I get root 2 over 2. So what I'm asking is, where does cosine of theta equal root 2 over 2? What angle makes this true? Well, when we think about an angle between two vectors, we want to think of it as being between 0 and 180 degrees or 0 and pi. Because, think of the two vectors that we have right now here, v1 and v2. I can think about this vector between them or the really long way around, right? We want to think about the shortest way around. So it's really just talking about the smallest the smallest angle between the two vectors. So what angle here would qualify where cosine of theta is equal to root 2 over 2? Well, on the unit circle, the two angles that make this true are pi over 4 and 7 pi over 4. So we want to use pi over 4. So in this case, we see that the angle between these two vectors is pi over 4 or 45 degrees. So what can we determine about the angle theta from the sine of the dot product? So this is just kind of thinking about the dot product a little bit more. Well, let's rewrite our equation or formula that we just had. So we have the dot product up here, and then the magnitudes down here. So what I see is that, so first we're thinking that, theta has to be between pi and 0, again, because we're thinking of the smallest angle between them, kind of the shortest way around. Okay. And so I really have two cases. So v and u are always, the magnitude of v and u are always positive. So they're not going to affect the sine of the right side. So if I'm thinking about what is the sine of this right side, well, v and u are always positive, so they're not going to be affecting it. So I really want to think about the sine of the dot product. Okay. So just from this equation, I'm going to have kind of three cases. I'm going to have v dot u is greater than 0. I'm going to have v dot u, the dot product, is equal to 0. And I can have v dot u is less than 0. So if that were the case, so let's look at case 1. So in case 1, v dot u is greater than 0. V dot u is greater than 0. Well, then this entire right side is greater than 0. Okay, because this is positive numerator, positive denominator. So if that's the case, then we're saying that cosine of theta is greater than 0, right? Because if this whole thing is equal to cosine theta, then whatever it's doing sine-wise, this is doing sine-wise. So what this is going to tell me is that then cosine of theta is greater than 0. Well, where does that happen? Well, that happens when theta is going to be greater than or equal to 0, but less than pi over 2. Okay, let's look at the next one. What if the dot product is equal to 0, like here in case 2? Well, think about our equation. If the dot product is 0, then I have 0 over something, right? Some number. Well, 0 divided by anything that's not 0 is just 0. So what that tells me is that cosine of theta is equal to 0. So cosine theta is equal to 0. Now, very specifically, when cosine of theta is exactly 0, then theta has to be exactly pi over 2. And then what about if v dot u was less than 0? Okay, well, let's go back up to our equation. If this is negative and the bottom is still positive, then cosine is equal to negative over positive, which is negative, right? So that is telling me that cosine of theta has to be less than 0. And if that is the case, then I'm over in quadrant 2, where theta is less than or equal to pi, but bigger than pi over 2. So this just kind of helps us to think about what is the relationship between the sine of the dot product and what we know about the size of that angle.